All right, so some more limits, but these limits are going to be at infinity. And I'll say this on the exam as well, but we need to be rigorous here. So what do I mean by that? I mean we're only going to use algebra and limit laws. It's a lot less hand wavy than looking at coefficients and degrees and stuff like that. So that's our requirement. Let's go ahead and get into it. So you could try and think of limit laws, but then you get like infinity over infinity, and that really doesn't work. The limit laws are a lot less useful for, some limit laws are less useful for limits at infinity. So our kind of standard trick here is to first divide the numerator and denominator by the highest degree in the denominator. So let's do that. Limit as x goes to infinity of 2x to the fourth minus 3x squared plus 1 divided by x to the fourth divided by negative 15 x to the fourth minus 37x plus 5 divided by x to the fourth. Okay. Now our next step is to be able to kind of use it's my birthday today, so we're gonna have a birthday plan. Okay. So our next step is to multiply these through and get something that looks a little nicer than this. So we have the limit as x goes to infinity of 2 minus, okay, I'll be a little, 2x to the fourth divided by x to the fourth minus 3x squared divided by x to the fourth plus 1 over x to the fourth. All of this divided by negative 15x to the fourth divided by x to the fourth minus 37x divided by x to the fourth plus 5 divided by x to the fourth. Now I can make this look even nicer by doing some cancellation. Right, x to the fourth divided by x to the fourth cancels out. And then we have x squared divided by x to the fourth. That'll cancel out with x squareds up here, and then this will go into a 2. Down here we have x to the fourth divided by x to the fourth. Those cancel. Here we have a single x divided by x to the fourth. That'll cancel down to 3. So now we have 2 minus 3 divided by x squared plus 1 over x to the fourth divided by negative 15 minus 37 divided by x cubed plus 5 over x to the fourth. Now I'm going to push my limit to the numerator and denominator. This is why I kind of said, I mean, they are kind of useful, just not always. So let's do this, and then we get limit as x goes to infinity of 2 minus, I'm going to go ahead and push this 3 out front as well, plus 1 over x to the fourth divided by limit as x goes to infinity of negative 15 minus, and I'll do the same here, push this 37 up front, 1 over x cubed plus 5 times 1 over x to the fourth. Now I'm going to push this limit all the way through to their terms, and we get the limit of a constant is a constant, minus 3 times the limit as x goes to infinity of 1 over x squared, plus the limit as x goes to infinity of 1 over x to the fourth, divided by negative 15 minus 37 times the limit as x goes to infinity of 1 over x cubed, plus 5 times the limit as x goes to infinity of 1 over x to the fourth. And then kind of our last step here is that all these limits are going to go to 0. This thing goes to 0, this goes to 0, 0, and 0. So we get 2 minus 3 times 0 plus 0 divided by negative 15 minus 37 times 0 plus 5 times 0, which is 2 divided by negative 15. Okay. Now our next limit, we're actually just going to follow that same rule, and then we'll add in something else. We're going to see that we might need something else. So let's just divide the numerator and denominator by the highest degree in the denominator, which in this case is x. And that's the same thing as multiplying by 1, so we're good. We haven't changed the limit. And now I'm going to rewrite this as the square root of 25x squared minus 11 divided by x plus 11 divided by x. Now, before I go on to this next step, I want to make a note. Note as x goes to infinity, x is positive, so the square root of x squared is equal to x. Right, if x was negative, this wouldn't be true, but x is positive, so this is true. So now, using that note, I'm going to replace this x down here with the square root of x squared. So we get limit x goes to infinity, square root of 25 x squared minus 11 divided by the square root of x squared divided by, I'll go ahead and do this thing. So 1 plus 11 over x. Now I can combine these two square roots in the numerator. So I can push this thing through the square root divided by x squared, and in the denominator we still have 1 plus 11 over x. And then now I'm going to do the same thing over here. Get limit x goes to infinity of square root of 25 minus 11 over x squared divided by 1 plus 11 over x. And now I should be safe to push my limit through, and we'll get some limits that exist. So I'm going to push the limit to the numerator and denominator. It's minus 11 over x squared. Limit as x goes to infinity, 1 plus 11 over x. And another limit law we had is we can push these limits through roots. So this is the root. The limit as x goes to infinity of 25 minus 11 over x squared over, let's go ahead and evaluate the limit on the denominator here. We see the limit of a constant is a constant. Well, let's first push this limit through to both terms. The limit of a constant is a constant, and then the limit of 11x is 0. 11 over x is 0. And then we'll do the same in the numerator, and we get the square root of 25 minus 0 divided by 1. And the square root of 25 is 5. Divided by 1 is just 5. All right, nice.